Hello. In this review, we'll be talking about the Soviet air-to-ground missile, the Kh-23, also known as AS-7 Kerry. This missile was intended to be the first of its class, but due to a number of technical difficulties, a simplified version of the same class, the Kh-66, was adopted first. I'll cover that one as well in this review so you can better understand what the Kh-23 is and why its development faced challenges. I'll also give you an overall picture of what this missile is and what it's capable of. Before we start, don't forget to subscribe to the channel and hit a like button. It really helps make our content better. Let's burn. Several events prompted the Soviet Union to consider that it also needed an air-to-surface missile capable of striking both moving and stationary ground targets, including armored vehicles, air defense complexes, radar stations, and train formations. One of the main drivers was the Cold War and the arms race with the United States. Since we're talking about the early and mid-1960s, the war in Vietnam also influenced the process. I've mentioned in earlier reviews of US equipment of the era that both the USSR, whose equipment was present in large numbers on that battlefield, and the US, which was trialing new weapons in Vietnam, were able to observe what each side had and draw conclusions about what still needed developing to avoid falling behind. That brings to mind the S-75 air defense system and the US anti-radiation missile AGM-45 Shrike. Both were covered in earlier channel reviews, links in the description. Earlier the US had deployed the AGM-12 Bullpup, an air-to-surface missile with radio command guidance, which was also used in Vietnam, and the Soviet Union had no analog. This discussion dates to 1963. On top of that, development of the MiG-23 had begun, and a new missile was needed, including one to arm that fighter. That combination of factors pushed the Soviets toward creating their own air-to-surface missile. Talk about it began as early as 1963, but full-scale development of a new missile didn't start until 1965. Before that, they considered adapting air-to-air missiles for air-to-surface use. OKB-134 began evaluating and making preliminary calculations for the new missile, which was designated Kh-23. That work took roughly a year. By 1966, it was clear that developing a new radio command guidance system would take time and require testing, because such a guidance system hadn't been used before. Yet there was pressure to field a missile quickly. They needed an answer to the United States. In 1966, engineers at Design Bureau of Plant No. 455, which had previously produced RS-2U missiles, an improved version of the K-5 air-to-air missile, proposed leveraging their experience, take proven, already available missiles, combine key components, and create an interim air-to-surface weapon while work on the Kh-23 continued. That's how the Kh-66 project began, also called Item 66, named for the year work started. Two well-known engineers, Korolov and Kokhlov, who led the Kh-66 effort, proposed the following layout. From the RS-2U take the radio command guidance equipment. That missile was guided along the beam of the carrier aircraft's radar. From another air-to-air missile, the K-8, take the PRD-25 engine. The missile normally had a nozzle mounted at the rear. From the unguided aerial rocket S-24, they proposed using the RV-24 Zhug non-contact radar fuse. That fuse allowed the warhead to be detonated at the optimal distance, enabling the resulting fragments to effectively strike the target. As a carrier, they proposed a modified version of the MiG-21 PFM fighter. It had already been modified to carry RS-2 US rockets, fitted with the appropriate RP-21M airborne radar and APU-68U launch rails for those rockets. What remained was to design the airframe, the warhead, and a number of less extensive components. They decided to use the tried-and-true duck layout for the new missile. That approach made it possible to build the first prototypes and carry out a series of ground tests in the same year. Work on the Kh-23 continued in parallel. Why focus on the Kh-66 in detail? Because the Kh-66 layout, with some modifications, was later used for the Kh-23. You can see that the Kh-66 and Kh-23 look very similar externally, and there are clear reasons for that. In 1967, new prototypes of Item 66 were produced and flight tests from the MiG-21 PFM began. The MiG-21 PFM would remain the only carrier aircraft for the Kh-66. That same year, a number of tests revealed shortcomings. The missile lacked sufficient maneuverability, was inaccurate, and there were problems with the warhead. Given the broad interest and the fact several factories were working on the missile, changes were made quickly. By the end of the year, the missile was sent back for further tests, and in 1968 a decree recommended adopting the new Kh-66 for service, which was done. The Kh-66 and Kh-23 share the same basic layout. The missile consists of 6 compartments. At the nose is the nose cone. Directly behind it is the compartment with the control actuator blocks, and the battery is mounted there as well. X-shaped control fins are mounted externally on the fuselage. Next comes a 103 kg shaped charge fragmentation high-explosive warhead F-66 with a contact fuse. Behind that is the compartment with a single-chamber, single-mode solid fuel rocket motor with a cartridge-type propellant charge, the PRD-204. This was an improved version of the PRD-25 engine used on the K-8. Whereas the K-8's nozzle is located at the rear, the Kh-66 has 2 nozzles placed on the sides of the missile because the guidance unit is located in the 6th compartment. The 5th compartment houses the sensors and electrical equipment, and on the outside of the fuselage are X-shaped stabilizers with aileron-type control surfaces. The entire missile weighs 278 kg. Its length is 3,631 mm, diameter is 275 mm, and stabilizer span is 811 mm. The Kh-66's guidance and engagement cycle worked as follows. After the MiG-21 PFM pilot detected a ground target, he had to slow to the launch speed limit, up to 1,000 km per hour, and go to the launch altitude of 5,000 meters. The thing is, the Kh-66's maximum engagement range is up to 6,000 meters. The aircraft then dove toward the target at the maximum permissible launch angle, 30 degrees. The pilot placed the aiming mark on the target and fired the missile. It took the missile roughly 1.5 to 2 seconds to enter the carrier radar beam that was locked to the aiming mark. The guidance equipment then generated signals to keep the missile on the radio beam line. Until impact, the pilot had to keep the aiming mark on the target and maintain the flight trajectory. He could not break off. The missile flew toward the target at a maximum speed of 700 meters per second and then struck the target. The warhead was capable of penetrating up to 250 millimeters of homogeneous armor. The problem was that the pilot couldn't evade anti-aircraft fire or break off from the target until the missile hit it. He also had to be able to see the missile in flight in order to correct its trajectory, which severely limited its use. It could only be employed in good weather. Yes, in the early 1970s an improved version of the Kh-66 was developed. It kept the same engine used on the Kh-23, swapped the battery for an improved power unit, and upgraded the guidance package. That made it possible to hit targets more accurately out to a maximum range of 10 kilometers. This improved version appeared in 1974. Most of the Kh-66's design was carried over into the Kh-23. The tail section differed because the Kh-66 housed guidance electronics that tracked the carrier aircraft's radar beam, while the Kh-23's tail contained the receiver for the Delta-R guidance system. The Kh-23 used radio command guidance rather than beam guidance. By 1967, 2 years after development began, the first Kh-23 prototypes appeared and factory trials started. The Delta guidance equipment was developed at National Institute of Informatics 131. The missile carried the Delta-R seeker, while carrier aircraft used Delta-N or Delta-NM transmitters. On some carrier variants, the Delta-NG was used in underwing pods. There were a number of difficulties and accuracy problems in the guidance system that required modifications to both the missile and the guidance set. The battery used in the Kh-66 was inadequate for the Kh-23, so they switched to the 9B16 power unit. The engine also lacked sufficient power, which led to a change of propellant. The warhead needed changes compared with the Kh-66. It was made more powerful and its fragment effect area increased, though it still could penetrate up to 250 millimeters of homogeneous armor. Factory trials continued for 2 years, until 1969. After addressing the problems, roughly a year was spent on refinements. State trials began in 1970. Because the guidance used a 3-point method, the pilot had to keep the aiming mark on the target and use a small control button, also known as the nupple, on the stick to steer the missile left, right, up and down. To do that he needed to see the missile during flight. So, unlike the Kh-66, a tracer was required in the tail. Initially, the tracer was mounted directly in the tail section, but that caused a number of problems. The guidance gear overheated and other issues affected reliability. The decision was made to mount the tracer underneath the missile on a special bracket. That avoided the earlier problems and allowed the pilot to observe the missile in flight. The first stage of state trials ran until 1972. Additional problems with the guidance equipment and stabilizers were found, in addition to the tracer issues. Wiring was replaced, several components were reworked, stabilizers were improved to make the missile track more accurately, and it was sent back for more testing. The second stage of state trials continued until mid-1973. After that, the Kh-23 was recommended for adoption and was accepted into service. Serial production began in 1974. The Kh-23's main combat use was in Afghanistan, but its guidance method made it problematic. Meanwhile, work on the Kh-25, which drew on experience with the Kh-66 and Kh-23, progressed, and the Kh-25 eventually replaced the Kh-23 in service. The Kh-23 was completely withdrawn from service in the 1990s. The Kh-23 missile is made of steel and aluminum with magnesium alloys. Its layout is similar to the Kh-66. It weighs 288 kilograms, of which 108 kilograms is the F-23-shaped charge fragmentation high-explosive warhead. Small preformed fragmentation elements, cube-shaped submunitions, are arranged along the warhead, 1,488 pieces total, which gives an effective lethal radius of about 40 meters. Both a proximity fuse ROV-19A and a contact fuse SKD-24 are fitted. The length of this missile is 3,591 millimeters, its diameter is 275 millimeters and stabilizer span is 785 millimeters. It can engage ground targets out to a maximum range of 8 kilometers, the minimum engagement distance is 3 kilometers. The missile uses a solid fuel rocket motor PRD-228 and has 2 nozzles mounted on the sides. The Kh-23's maximum flight speed is 750 meters per second. The launch aircraft had to approach at a speed up to 1,000 kilometers per hour with a maximum dive angle of 30 degrees. There was also an option to launch in level flight. In that mode, the engagement range was up to 5 kilometers. Carriers of the Kh-23 included certain variants of the Su-17, MiG-23, MiG-27, Yak-38 and Su-24. To use the missile, carrier aircraft were fitted not only with the Delta guidance equipment but also with the Apu-68U rail launcher from which the missile was released. In 1976, an improved version, the Kh-23M, was developed. It received an upgraded F-23M warhead weighing 111 kilograms, improved wiring, an upgraded Delta R-2M guidance unit, and a more powerful and brighter tracer, so the pilot could better observe the missile in flight. The 9B-16 power unit was replaced by T-454 batteries. In the 1970s, the Archon guidance system was also developed for the Su-24. That system used the Terran R missile direction finder, which enabled semi-automatic guidance of the Kh-23. Terran R measured the missile's angular coordinates and fed them into the command line. The Kh-23 and its predecessor, the Kh-66, laid the groundwork for a family of missiles with different guidance methods intended for attacking ground and surface targets. Many descendants are still used today, although they are technologically outdated. So, that was the Kh-23. I hope the video was interesting and informative. Don't forget to subscribe to the channel and hit a like button. That's all from me. Wishing you clear skies. Bye.